So this is a video about how to calculate the approximate particle size for your nanoprisms in the Measuring Really Small Things lab, the second part of it. So at this point you'll have some data. What you'll have is the lambda max, the wavelength of maximum absorbance for each of your test tubes, labeled with how many microliters of potassium bromide has been added, 0, 20, 25, or 40. The particle size you get from the table in the handout for this lab. You have that already. So we're going to graph particle size on the x-axis, lambda max on the y-axis. Remember, the x-axis goes first, y-axis goes second. Now here in my data, this, by the way, this is data that I got by using Matt's solutions that he made. There's something going on with the zero test tube 0, and I think from what I saw, most people had something going on with that. So we're going to eliminate that data point and only graph the 20, 25, and 40 test tubes, microliters of potassium bromide added. So highlight the data. I'm using LibreOffice Calc. If you're using Excel or numbers, the procedure is slightly different, but at this point you probably know how to do it. Select data, click Insert, Object, Chart, click XY Scatter, Next, 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 insert the title, wavelength versus particle size, subtitle, put your name, label the x-axis and y-axis. X-axis is particle size. Units are nanometers. Make sure you get the units in there. Same thing for the y-axis. That's wavelength. Units also are nanometers. All right. Display the x and y-axis grids. Finish. Get rid of this. Next, we're going to scale the axes. So left click on the y-axis, then right click on it. Click Format Axis. 0. We don't want to start at 0. The minimum is going to be at 410. No, more like 450, 460. Let's call it 460. The maximum is going to be about, let's call it 635. That's my data. If yours is different, you scale yours appropriately. All right. Same thing for the x-axis. Left click, right click, Format Axis. Minimum is 20. Maximum is 40. Now, next thing we want to do is we want to insert the best fit straight line. So right click on any of the data points, click Insert Trend Line, click Show Equation. Okay, you got it. Move it up somewhere where you can see it because you're going to print this out. Remember, f of x is y. There's our slope. My slope is 7.923 or so. My y-intercept's 296.8 or so. So once you have this, then all you have to do to calculate your particle size is you're going to put the lambda max for your unknown in here for f of x or y. Solve this equation for x. X will be the particle size in nanometers of your unknown. So I don't remember all the numbers. I just remember that many. So we're going to solve for x, the particle size. All you do is plug in lambda max that you measured for your unknown, and you get your answer. For I don't remember the numbers, but for your slope and y-intercept, if you used calc, you don't have to use all those numbers. 3 or 4 sig figs for each is fine, and that's it.